Hi everyone, welcome to another edition of Coffee and Commits. This is the third one so far. If this is the first time you're joining us, these are regular syncs with o1Labs where we kind of share regular updates into what's happening across Mina, tooling, ecosystem projects, kind of a behind the scenes. Sorry, I had a bit of an echo there. Just what's happening behind the scenes at O1. The calls are intentionally high level and digestible, but you can find deeper dives for most of the things on our blog or on X. And you can always reach out if you want more details about any of the topics that we've talked about. Before we kick off, I will give a quick run through of the agenda for today. So we have Nicole joining us to give kind of top of mind and just some insights into what's been happening behind the scenes at o1Labs and some of the topics that we've been exploring. Then we have Florian joining us to give a demo on some of the stuff that he's been working on. We have a Mesa update from Yami, and then we have ecosystem updates from Haresh. This is a bit shorter this week, but we will have some ecosystem guests joining us next week. So I will hand over to Nicole and bring you up to the stage. Hey, Nicole.
Hi, Becky. Hi, everyone. Welcome to another Coffee and Commits. It's nice to be back. And for today, I want to cover some things that I'm noticing across the industry, some broader trends we're looking at, and the work we've been exploring behind the scenes. So first, on the regulatory front, there's a lot that's been happening. And as some of you know, I'm a lawyer, so I take particular interest in regulatory developments. The conversation around digital and assets has really shifted a lot over the last year. I haven't focused as much on international regulations, but just off the top of my head, MiCA in the EU was passed a few years ago, but now is in full swing. Some key implementation deadlines just passed, I think it was July 1st, that could have some big implications for crypto. UK, Hong Kong, and the UAE have all passed digital asset or stablecoin laws in the last year. In the US, there's been a lot of growing momentum towards providing clearer frameworks. Genius, which was the Stablecoin Act, passed last year, and we're seeing how having clear rules really unlocks economic growth. There's been so much growth with stablecoin activity over the last year. And then the latest is the Clarity Act, which is the market structure bill. And policymakers are trying to define roles, responsibilities, and overall market structure. And it hasn't been passed yet, but it's moved through some key Senate committees. And we're hoping that it will get voted on any day now. It's kind of a roller coaster ride. Like the rumor was 2 days ago that I think actually the latest version just came out. But then yesterday, I read that some key Democratic senators, including ones that actually support crypto overall, are against it. One of the main blockers on this law is an ethics provision that Democrats are insisting on having. And I personally think it's good to have ethics, but it's just, hard to come to an agreement. Anyway, we're keeping our fingers crossed that it will pass within the next month before they take their summer August break. I just want to highlight again how important the regulations are, because it really allows people to build and know what the rules are and level the playing field for everyone. Okay, so that's it on the regulatory front. The next thing I want to talk about is some trends that we're noticing. Sure, you're not surprised that I might talk about Agentic AI. It's become one of the biggest conversations in technology. And I've read a few things recently that I think this kind of, to me, describes what's happening just broadly. So, when LLMs first launched, like the first one with ChatGPT, the idea was there was this tool that could help you. And we evolved from having a tool to having a coworker, something that works alongside you. And now we're moving beyond that to building AI systems that can actually just do the work that people do and replace people and make decisions. So it's really exciting developments, but it's also kind of scary. Just this week, there was some chatter on X because I'm trying to think. It was OpenAI had a model they were testing, and it broke out of its sandbox environment and tried to cheat on some sort of test it was being given. I mean, it's kind of funny, but it's also just terrifying. Like, how can we trust these systems? How can we trust that they're going to do what we've told them to do? And how do we know that they're not going to deceive us or give us trustworthy outputs? So we need to verify that they're staying within whatever rules we've set for them, and we also need to be able to audit what they did. So all of these things make me think about cryptography, and we've talked a lot about ZK gated execution and how that can allow for verifiability and auditability. And I think there's a real chance for cryptography generally to help with agentic AI. So let me think if I've covered everything. Oh, I guess one more thing I wanted to mention is that we're also looking into confidential computing. So what is confidential computing? Encryption protects data when it's at rest and when it's being sent over the internet. But the missing piece is protecting data while it's being processed and computations are being performed. And so as computing moves more and more to giving responsibility to LLMs, companies don't want to share their data with their cloud providers or with the LLM providers. And in many cases, they aren't allowed to share their data because they're in regulated industries like financial services or healthcare. And so confidential compute is this kind of developing space that's using things, different types of cryptography and encryption. ZK might be one piece, TEEs might be another, but to provide full confidentiality and protect data. So we're very early in this space, meeting with some other builders in this space, some possible customers and researchers, just to understand where the technology can have the greatest impact and where we can bring the most value to customers. So that's enough for me. And now I will hand it over to Florian, who will share some insights on our research and also on a demo that showcases the use of ZK for agents. Thank you.
Awesome. Thank you very much, Nicole. Yeah, that was a amazing intro, I guess, and I think everyone knows that AI agents, LLMs, they're currently very, everywhere, I guess. People are using them actively. Lots of things are happening, especially in the Web3 crypto scene as well. Lots of vulnerabilities being discovered by, state-of-the-art LLMs and stuff like that. So, and, o1Labs is an expert in cryptography, verifiability. So, we thought maybe there's something we can do leveraging our skills to make the entire internet and, everyone's life a little bit more secure and prepare everyone for the agentic age, I guess. Next slide. So agents, like I just said, agents are now taking real actions in the real world. It starts with simple bots being active on Twitter. It reaches into agents doing on-chain payments. There's a lot of standards being developed in the Web3 world for blockchains, for agentic payments, and stuff like that. So this is becoming a real thing. And due to the state-of-the-art models as out there, both closed source as well as open source, the capability and the intelligence isn't really a problem anymore. That is kind of solved, I guess. Models have gotten incredibly smart. As everyone that's a software engineer that has written code before knows that, state-of-the-art LLMs are much better code writers than any human could ever be. So yeah, capability is no longer really a problem, but now trust is. The entire trust machinery that we know as of now, that we know from the old quote unquote like software world, mostly runs on promises. Software is mostly deterministic. We kind of know what happens, and there's like no real threat to that software, right? existing controls, they are usually at the two extremes, I guess, either pre-execution or, bay at the end of the entire execution chain. But the thing that, I guess we have been thinking about here at o1Labs as well is what kind of happens in the middle. How can we define boundaries within the middle of the entire workflow so that whatever the agent is doing, nothing will kind of get messed up or nothing bad happens. When I was building the example, the demo that I will show in a second, I kind of set up a marketplace of agents. I told my own personal agent to, I gave him a list. I specified what they are supposed to do. They were supposed to go out and build buy aerospace material to build a spaceship, and they ended up purchasing bamboo, which is a funny little story, I guess, and that kind of, for me at least, highlights the necessity of guardrails, enforcement, and making sure that whatever agents are doing is actually, what we want them to do. Next slide. It's hard to, prove that an agent or like an LLM made a good decision. It's not really a thing you can do. Instead, we're kind of trying to prove that whatever the agent or the LLM is doing stayed within the policy that a human, defined at the beginning, that a human approved. The agents are proposing actions. They're being by default treated as untrusted. We don't know what their intentions are. We don't really know, their final goal. So we're kind of, we're careful there. We make sure that everything we look at from the agent, we're treating that as untrusted. And we're trying to like enforce, we're trying to enforce that each action the agent is taking, follows a previously approved policy deterministically. And the idea is to essentially use CK for that. And as an output, we get a small portable cryptographic proof that we can give third parties, potential customers, potential supply chain, partners, potential other companies that would like to, transact with us, communicate with us. And that allows us to kind of like have a small portable receipt to, kind of like prove that the agent was moving within the predetermined bounds or policies that the human has told them. Next one, please. So as everyone knows here, kind of, hopefully, CK itself is not a free technology, I guess. It takes real resources. It's cryptographically very, very heavy. So these receipts, they are not, free by default. They require you to put in proving time. They require you to have memory resources, and stuff like that. So not every workflow will need them. There's different levels of guarantees, different levels of, I guess, security depending on the workflow. But for some of these workflows, it might make sense to use CK, put in the extra effort to really make sure that the agent is behaving within the bounds that we determined before. So, and that really, really matters when a few conditions are met. Essentially, when we want to interact with someone that doesn't trust the operator, but we need to convince them, right? It also matters when the inputs are sensitive because CK, that's the zero knowledge part in CK, it hides the inputs. And it also matters when work is being delegated. And when we achieve that by using CK, the entire claim stops being, trust us, trust the agent, whatever, to, just look at the proof, verify it yourself, and that will be, very efficient. Before I start the video, I'll just give a quick overview of what's happening, and then I'll talk over the video as the video is, doing its thing. So the demo essentially is a supply chain. The user at the beginning, they define a policy, for example, go buy something for me, follow a certain policy, make sure you don't spend more than X number of money and stuff like that. And then the agent goes ahead, spins up different sub-agents, and these sub-agents then, go outside to a marketplace, for example, or to other partners. They communicate with these other agents and try to find a deal, essentially try to fulfill the original policy. And along the way, every agent is generating a small succinct CK proof, which are then being, all recursively aggregated so that you, the operator, is, has a small portable cryptographic receipt left that verifies the entire interaction chain. So yeah, next slide, please, for the demo.
It seems the demo hasn't loaded, but I can, if you have the link to the video, I can share that, or if you want to share screen, you can as well, Florian.
Yes, give me a second. I think I should even be able to share a video directly. That's very nice.
Yeah,
Okay,
I can
let's
stop
see.
sharing screen and then you can add yours. Let me remove this one.
Can you, I got a screen here. Can you like open it maybe? Oh, there, yes, perfect. Awesome, cool. Yeah, looks like it's working. So yes, the idea is to define a policy, a human defines a policy. That policy could be, for example, I'm telling my agent, hey, go out and buy personal data that's compliance certified. It's only within approved jurisdictions, only certain countries. It covers a certain data class, and don't spend more than $50,000 essentially. Is it still blurry? Let's see. I did stop it for a second. Let's see if when I continue the video. See if that works.
It's still slightly blurry, but I can mostly see it. Now it looks better.
Okay, cool. Let me just quickly restart it then, and let me just go from the beginning. So yeah, this is the policy. A user defines it. They can use plain, language, human language, and AI converts it into like a structured policy, and then the human essentially approves that policy. And once the policy is approved, we can then, give that to our agent, the orchestrator. The orchestrator splits up the entire policy into multiple, sub-agents. Every sub-agent takes care of one slice of the original policy, and then they all go out into like the open wide web, a predefined marketplace, and talk to potential, suppliers for our initial policy, and they interact with each other. So it's like a marketplace. You can see on the left side, it's like our internal, quote unquote, company, internal organizational agents. And on the right side, these are like third-party agents that are talking to our agents. They all interact with each other. They fulfill, the policy that we have. They provide a small verifiable CK proof that they actually have the data, that they are authorized to do that. And as the entire agent chain is processing, we can then recursively verify the entire CK proof. So the chain, the entire interaction chain is then being, certified or proven by a tiny CK proof that whoever needs it can then essentially, use it and send it around and verify and make claims or statements about the entire thing. And yeah, that's one of the things we have been working on in regards to agents, AI and verifiability of those. So yeah, thank you.
Thanks, Florian. We have a blog post coming out soon as well, which runs through a lot of this as well. And we can share this demo probably on X as well, in case anyone wants to kind of go through it again. Thanks, Florian. I'm going to bring up Yami to give the Mesa update. I'm also just going to change the slides back over. Here we go. Hey, Yami.
Hey, thank you. Okay, so where are we with Mesa? We are on the road to DevNet now. So Mesa Trail and the Trailblazer program was successfully completed. And we worked right after that finished to decide what we needed to set up for the DevNet upgrade. We scoped all of that. Most of the work is underway and close to completion already. So what does this mean? What have we been doing right in the meantime? So after MUT, we did a deep validation of the network state for the MUT network and also for the pre-flight network that is still active in preparation for final testing, because there were a couple of issues with archive nodes data. So we wanted to make sure we had proper ways to fix all of them in case anything went wrong. We've already fix them and have mechanisms to fix them if it happens again. We finalized the new release candidate with all of these fixes, plus all of the user experience feedback that we got. So we added quite a lot of things to improve everyone's experience, hopefully. And we're in the process of testing this release candidate comprehensively. So we did a small, what we call a small dry run, which is basically without user participation. It's, Darius and Luis like doing the hard fork process. I think this is attempt number 19 already. We've done a lot of dry runs internally. That was very successful. All went very well with the new release candidate. And right now, as we speak, we're in the middle of a company-wide dry run. What does this mean? We actually bring in users, like from the company, right, who act as node operators during the dry run. In this case, we actually brought in people that had never done it before to test the user experience from scratch. So we hard forked yesterday. Everything went very well. Right now, we're in the validation process. And we are running also cluster tests. The load testing we did during the MUT network, the Trailblazer program, we are running the whole test cases again. And this same network that we spin up for this dry run will become the new stable network for Mesa for public testing, which we will open probably next week to everyone, which will have the latest version of everything. And this is a network to which we will also call eventually soon exchanges to do the final testing before we move on to the actual hard fork. We've also released the backwards compatible Mina signer. This is Mina signer version 4.1, and that can be used for both Merkle and Mesa. So anyone who is using the Mina signer can already update to this version, and when the upgrade happens, it should work without any issues. What's happening next? We are, as I mentioned, we're opening the Mesa Trail network to the community, the one we are working on right now, the most stable and most updated version of all. We will call in exchanges for final testing and upgrade readiness. We will set the date for the DevNet upgrade, and we will also start working on releasing the packages for the upgrade. So we are quite busy, quite excited as well, and we're quite close. Thank you so much. Now moving on to Haresh, who will have community updates for you.
Thank you. So from the ecosystem side, a lot of the updates are centered around audits, as all of these applications are getting production ready. So the first one being Nori, which is the ZK bridge, who's currently undergoing an audit with Zelic. They're very close to finishing the audit along with the fixes, and we are expecting the report to be out in a week's time. The Frost multisig wallet audit is now complete by the Veridis team, and the report should be up. The decentralized treasury from Mina Foundation, their audit has also been completed by Trail of Bits and ZK Security. I believe this was done a couple of months ago, but the reports are now up and available for everyone to view. Obviously, there's a lot of ongoing support provided to critical infrastructure projects such as wallets, block explorers, as we are moving towards Mesa. Having all of these projects come and deliver would be interesting and exciting to see. So that's all from the ecosystem updates. I'm going to pass it back to Becky.
Thanks, Haresh. It's a shorter update this week, but we just posted a Q2 ecosystem update blog as well, so you can kind of read more updates there if you want to learn more. We've also just sent out an email to all of the subscribers with this information as well. If there's anything you want to hear about next month, let us know and we'll try and include it. And if not, then we will see you on the next one. Thank you, everyone. Have a great day.